So our next lab is a 2-week lab. First part of the lab is just going to be on experimental acquisition of data. The second part of the lab is actually going to be fully devoted to calculations. So one of the labs that we're doing here is like a lot of the labs that we do, which is we're looking at a chemical reaction and maybe we don't know something specific that's happening to it. So in this case, we're looking at the decomposition of potassium chlorate. So it's going to eliminate some oxygen, and depending on how much oxygen it eliminates, it makes one of 3 possible compounds. Eliminating all of its oxygen is going to generate potassium chloride. Some of its oxygen is going to eliminate potassium hypochlorite, and then just a little bit less, and we're going to have potassium chlorite. So 3 possible options. And what this lab is about is using experimental techniques to obtain experimental data that we can use to figure out which of these possible options is occurring. Okay. So again, the focus of the first week's lab is really to acquire experimental data. So here's the experimental pieces of data that we're going to be obtaining. We are going to know with a high degree of accuracy the amount of potassium chlorate that we start with. Then we're going to let this reaction happen, and we are going to determine what mass of solid remains. And then importantly, this is a gas law lab, we are going to be collecting some data that's going to allow us to determine the amount of oxygen that we liberate. And using the ideal gas law, we're going to know the volume of gas we liberate, the temperature of the gas, and then the pressure of the gas. All of those pieces will allow us to ultimately determine the amount of gas that we liberate. Okay, so how does this all work together in terms of the calculations? There's 2 kinds of calculations that we're going to do, and we're going to see if they're internally consistent in terms of telling us which of these do we make. Okay, the first one is called a volumetric analysis. Why we call it a volumetric analysis is we are going to be using the volume of gas that's liberated to generate some data that's going to allow us to determine how much oxygen was actually generated, and then use that to make an estimation as to what product we made. So let's see if we can see how this works, right? These are going to be stoichiometry calculations. Okay, so if we know the mass of potassium chlorate that we start with, molecular weight can get us to the moles that we start with, and then what we're going to do is we're going to tie this quantity of potassium chlorate to a theoretical or predicted amount of oxygen that we can generate depending on which reaction we have. Now, this might make a little bit more sense when we talk about calculations, because I have X, Y, and then different possible options here, because the stoichiometry, the values of these coefficients are going to be different depending on which potassium salt that we make. So again, stoichiometry can allow us to determine a predicted number of moles of oxygen that we're going to generate. And then using PV equals nRT, right? There's 4 properties that describe a gas: the pressure, volume, temperature, and quantity in moles. Those are all equal to our R gas constant. So we can use, again, our R gas constant and 3 of the 4 parameters to determine the one that we don't know. So we will determine the actual amount of oxygen that we made, and then compare that to, for these 3 separate reactions, what is the predicted amount? And like we've done before with so many things, we're going to see which one of those match up, and that's going to be, evidence that suggests one of these 3 possible products. Okay, so that's volumetric analysis. That's again a calculations that's going to use the volume of gas that's liberated to determine sort of how much predicted oxygen we make. And then again, we'll use calculation to determine the actual amount. Okay, there's going to be a second piece here, and this is also going to be stoichiometry, but now we're not connecting to this product. We're not connecting to the oxygen gas that's liberated as a product. Rather, we're looking at the mass of the potassium salt that we make. So similar kinds of analysis here. This is called gravimetric, gravity meaning like weight and so forth. We're going to measure something. We can use stoichiometry to predict the amount of each of these different salts that we'd make in terms of a mass, and then we can compare it to the actual mass that we got. That one's going to be a little bit easier in terms of the comparison piece, because we can just figure out what the mass of product is that we made, we actually had to do a calculation to figure out the moles of oxygen. We don't have a mole meter that we can figure out the mole of oxygen that way. So same kind of a thing though, predicted amount of solid product that we'd make, compare it to the actual amount of solid product that we'd make. Look here that I wrote this potassium salt as KClOx, knowing that this X could either be essentially 0 if we have KCl, 1 if it's going to be KClO, or 2 if it's going to be KClO2. Okay, so we're going to gather that experimental data this first week, do our calculations the second week. So let's take a look at what this experimental setup is going to look like. Okay, so I highly encourage you to watch a video that Dr. Brown has put out on what this experimental setup actually looks like, because looking at it just with sort of this diagram is just not the same thing as seeing it in real life. Here's some important pieces that you're going to want to note. There's going to be a setup over here where it's going to be your heating setup. You're going to have a Bunsen burner. You're going to have a test tube here that's going to have your sample that you're heating. And then we've essentially got a system of tubing that's going to collect the gas that's evolved here. And it's going to let that gas go into this Florence flask that's filled with water. Now, as the gas goes in here, we're going to push the water out, and then the water is going to be collected down here. So some important pieces here is there's going to be a clamp that's going to be here. Now, that will be an important point that sometimes that clamp will be closed, sometimes the clamp is going to be open. You need to make sure you know when it's closed and when it's open to properly run your experiment. Importantly, when you're starting to run your experiment and you're liberating this gas, you do not want that clamp to be closed. That's going to cause a problem. We also have water levels that we need to sort of make sure that we compare and look at accurately here, because if those levels aren't equal, then atmospheric pressure is going to be artificially increasing or decreasing the amount of water that we're going to be looking at. So those are a couple of important things to think about. Make sure you see how this setup works when you get yourself into lab. So here's some other experimental pieces of data that you're going to be acquiring. A lot of it is going to be the mass of the substance that's in your test tube. Well, that's really hard to acquire because, you don't want to take the stuff out of the test tube, because what if you didn't get it all out or some of it spills? So here's how we tend to do things like that. You're going to make sure that you know the mass of your empty test tube. Then you're going to add your test tube and your potassium chlorate salt. Okay, you're going to know this exactly, and then the difference between the two of these will give you the mass of the potassium chlorate that you added. And then you're going to do your experiment, and after the experiment's done, you're going to weigh that test tube assembly again. And now we don't know exactly what the potassium salt is that's in there, but looking at the difference between these two data points, you are going to be determining the mass of the salt that you generated. Another piece of data that you're going to acquire is you're going to be measuring the volume of water that's displaced as oxygen is liberated and it pushes the water out of this system. So in that way, the volume of water is going to be a proxy for the volume of oxygen gas that's liberated. Okay? So you're going to be gathering some data here. You're probably going to do at least 3 trials, okay, maybe more depending on how consistent your data is, right? Looking at some of these, we're going to take the differences of some numbers. Actually, I should say it's the difference of these two numbers here that's going to give us the mass of our potassium salt product. Some other pieces of information that we're going to have to make sure that we write down that are actually dependent on whatever day you have lab. The atmospheric pressure can be changing depending on what the weather is. We need to make sure we take down the temperature as well. But note here that just looking at that atmospheric pressure is not going to be the total picture that we use in our calculation, because we are going to need to subtract off the fact that our gas is collected over water. So we're going to need to look up what is the vapor pressure of water at the temperature that we're at, and that is going to ultimately get us to the partial pressure of oxygen. So lots to think about there. Ultimately, what we're going to have is a whole day, again, to look at these calculations. So I want to go back just for a second here to sort of summarize and remind you about the experimental pieces of data that you're collecting for this first week of experiments. Okay, we are going to, again, you're going to know the mass of your test tube, and then you're going to weigh the test tube with your potassium chlorate salt, and then that difference is going to be the mass of potassium chlorate that you have. You're going to do your experiment. Again, you're going to be collecting information on the volume, temperature, and pressure of the gas that's liberated. And importantly, you're going to weigh your test tube at the end. We don't know the identity of the salt that's in there at this point, but the difference again of that mass and the mass of your empty test tube is going to tell you the mass of that potassium salt that you have. At this point, you've gathered all of the experimental data that you need, and we're just going to hold on to that because next week we're going to work on doing our calculations.